All right, so warm up number 33 is on the screen. And one reads, write the compound inequality shown by the graph. They give us a number line. And on that number line, it shows that there's a red graph starting with a solid point at +4 and going to the right with arrow at the end. And then there's another green graph starting at -2 with an open point and the arrow going to the left. Number 2 says solve. It's a rational equation, and we have -2x minus 16 over x squared plus 15x equal to 1. And number 3, it says write the equation in the to the function graph, and they give us a coordinate plane, and there's a blue line graphed on it. And reference points, I'm going to give you -3, -2, and 6, 1. -3, -2, 6, 1. So place those 2 points, sketch your graph, and write your function. And I'll give you guys some time to finish that warm up. Let me get my dog out to the back here. Give me a second. I'll be right back. All right, so the answers to the warm up are there on the screen. Make sure you check your work. Here's for this, for number 2, and for number 3. All right. Our agenda for today, we have warm-up number 33, which we already finished. We got transforming functions. Today we're moving on. And then we're moving on to our home plate, which is, I'm going to give you 2 problems. They're going to be on the screen in a little bit. And also page 41, you're only doing numbers 1 through 4. Don't go beyond that, or else you're going to get confused. So once again, only 1 through 4 on the page 41 from your book. And I'm going to give you 2 problems on the screen in a little bit. All right, from there, our near-pod code, asynchronous code is QPT8S, QPT8S. You're gonna need that because right now I'm gonna move forward with a home play. I'm not gonna leave it on the screen much, just so that it's recorded on the video lesson, but I'm moving on. Also, your previous home play, which is pages 17 and 26, all only. You are going to turn into Canvas, but not right now. Turn it in towards the end of lunch. I'll give you guys some time. It's still not on Canvas because I'm going to do that right now when we break for lunch and to save time for the lesson. Tonight's home play, it says do the indicated transformations to the following functions. For part A, it says graph f of x equals 2x plus 1 using the domain -2, -1, 0, 1, 2. And the transformation for that, it says transform and graph using f of x plus 3, that's in green, and f of x minus 5, that's in red. For part B, it says graph f of x equals x squared using the domain -2, -1, 0, 1, 2. And the transformation for that in graph, it says in green, f of x minus 4, and in red, f of x plus 3. And part of the home play also, page 41, numbers 1 through 4. Okay, once again, you can get that with your asynchronous code. All right, so in the meantime, copy this one, please, on your paper really quick. We're going to do this one together just to do a quick review. I'll give you some time for that. 2 minutes. Copy that. All right, so reference points, they give us this point right here, which is right below 2. And each on the Y, they give us 1, 2, and 3. And for 1, it has 4 partitions, 1, 2, 3, 4. Same thing for 2 and 3. For the X values, it starts at 0 and it goes all the way up to 20 by 2s. And notice here for the X, it represents months and time. For the Y, it represents the value in millions of dollars for the Y. And it's a curved function. All right, so this is a quick recap of what we did in the past couple of sessions. Oh, sorry. And let's see how well we do with this. And it says, The graph shows a function that models the value V in millions of dollars of a stock portfolio as a function of time in months over an 18-month period. 18 months, there it is. So it says, on what interval is the function decreasing? Decreasing. I'm going to do that in red. So if I look at this function and I start here, it looks like it's going up to right there. But then all of a sudden at this point, it starts going downward. And it stops going downward at about right here. So I hope you agree that it starts going downward. Where does it start going downward? At 3 months, and it stops at what? 13 months. So it goes from 3 to 13. Because it says on what interval? What interval? All right, with that said, see if you can write the interval for when the function is increasing. Do that in green. When the function is increasing. Increasing. Okay, let's see. So if I start here and it starts going upward up to right there, that's true. So it starts increasing from 0, which is here, and it stops increasing at 3. So it goes from 0 to 3. So it increases from 0 to 3. Is that the only place it increases? No. It increases here. Where else does it increase? Oh, it starts going up again here, Mr. Q, from here to here. So from 13 to this point, which is 18, 13 to 18. So my other increase is 13, comma, 18. Hands, have you got that? Okay, good. It says identify the max values and the min values. So look up to the screen really quick. From here on, we're going to start looking at functions which are quadratic functions, cubic functions, which is they're going to have curves on it. So whenever you have quadratic functions and you have parabolas that look like this, whenever you have a parabola that looks like this and there's a low point, that's our minimum. Whenever it has a high point, this is a maximum. Minimum, maximum. Same thing with this kind of function here. Do you guys see the minimum and the maximum? This one has a combination of both in it. Yes, Mr. Q. Here's the max and here's the minimum.
Okay. Mr. Q, I have a question.
Yes.
Wouldn't the maximum be where 18 is? Because it's the highest point?
Right, no. Right now we're looking at just within the function, no, not at the ends of the functions.
Okay.
Okay. All right, so with that said, let's write our domain and range using the interval notation. So let's see. The domain for this function here, this function starts at x0.
Wait, Mr. Q.
Yes.
Are we supposed to write down the point that the minimum and the maximum are, or are we just supposed to circle it like on the graph?
For right now, I just wanted to show you that. You can write the coordinate, but for right now, as long as you identify them, that's fine.
Okay, thank you.
Okay, so here we go. It says write the domain and range of the function. So it starts at 0, and if I was to highlight the function going all the way to the right, where do I stop highlighting? I stop at what? At 18. So my domain is from 0 to 18, and this is in what? In months. Okay, now let's go with the range. Be careful with this one. If I start highlighting from the bottom to the top, where is my first highlighting beginning? It's going to start about right there. And I continue highlighting upward, and I stop at about right there. So let's see. However, notice that here is by million. So that means this is 1 million, 2 million, 3 million. So where does it start? Does it start at 1 million? No, it starts one partition before. And each partition we said is divided by 4. So that's 250,000. This is 500,000. This is 750,000. So I'm going to write my range is 750. I'm going to put TH as 1,000, comma. To what? What is the highest range on this one? 3. I'm going to put 3 million. 3 million. All right. All right. Show me your fingers. I'll continue. You are just analyzing characteristics of a function. Up to right there. We good? 1 being the lowest, 5 being the highest. Yeah. 5, 4 is 3, 5, 4, 5, 4. Okay. All right, that was a quick review of what we saw so far, but let's move on. I wanted to get us to the session for today. Our objective for today, I can transform a function using different parameters. Once again, our objective for the lesson today is I can transform a function using different parameters. So what is it that we know from there so far? We know what a function is. Yes? Yes, Mr. Q. Do we know what the word transform means? Yeah, changing into something else. Yes, so we know those two. So which is the new term that we need to clarify? Parameters. Parameters, that's the new term that we need to clarify. But we should know what functions are. So functions, you should be able to fill one of these up by yourself. Definition, example, non-example, and a hashtag in your own words. You can do that on your own. Let me get to the term, which is parameter. What is a parameter? So today we're going to be looking at transforming original functions into another function. When I ask you to do that, I usually will give you a number by which you transform it. That number is known as a parameter. That's why the definition for a parameter is a number that transforms a function into another function. A parameter is the number that transforms a function into another function. Okay? Yes, Mr. Q. All right. Once again, this is in the presentation, the asynchronous one, so you can copy the definition exactly how it is if you want, but that's the definition. All right. So it brings us to this portion. Writing utensils down, look up to the screen. Look up, please. So we started off our school year, and then we did, numbers, expressions. From there, we moved on to equations and so on and so forth. And then once we got to 2-variable equations, we looked at stuff like this, where the 3 is the slope and the -1 is the y-intercept. So far, so good, yes? And we fill out tables that look like this. Usually the domain that I give you is what? From -2 to what? To 2. And we're going to do the exercise as to how to fill this in, but we should know how to fill this in by now, yes? Substitute the -2 in here. Substitute, that's -2 times 3, -6 minus 1, that's -7. And once again, you're not copying this. This is just a quick review of what we've seen. But what did I say then? Once we got into functions, we no longer call it in 2 variables. It's called function notation. We changed the y to what? F of x. Is that correct? Yes, Mr. Q. So what does the table look like? It looks about the same. The only thing, instead of the y, what do we write now? F of x. So from this point forward, we're going to be focusing now on just f of x or any other function notation. Okay, so let's say I start with this one. And right now you're just paying attention. My goodness. So today, I'm going to just give you a step closer to what we're going to do. Check this out. You're not copying this, you're just paying attention. So if I was to give you this table, which is that function, I'm going to be asking you to do a transformation that looks like this. F of x plus 5. Now pay attention or you're going to miss it. Write your utensils down. So this was my original function. F of x equals 3x minus 1. And I got these as my domain, and my output was this, my function of x. But now they want me to do a transformation. Look up. They asked me to take the function of x and add 5 to that. Look up, please. Look at my table. Which one is f of x? Not this one, it's this one. So that means I'm going to take the first value, which is what? -7. If I substitute this in here, what do I need to do after -7? Add 5, and what do I get? -2. Let me write that in here so you guys can see it. What is f of x? F of x is -7. But this says to do what? +5. So what is -7 plus 5? -2. So if I wanted to do each of these transformations, so my next value is what? -4. So that means if I substitute that in here, it should look how? -4 plus 5, which is 1. You guys see it? Okay, so at this point, copy this really quick and finish up the table. I'll give you about a minute. About a minute, I said. Oh, yes. All right. So for this one was -2. For this one was +1. What would be the next value, Addie?
I put 4.
That is correct. About the next one, Jaziel?
Would it be 7?
That is correct, 7. And our last one, Danny, what would be our last value?
10.
10 is correct. And what we just did, we did a transformation of the original function by the parameter of 5. Once again, this number, what is this number called? Parameter. Parameter, because that's what made us transform the original to this. Okay? So I gave you the work for this, and I gave you this and everything here. So what I want us to do, I'm going to take it step by step so that we can do the process so that you can see how everything is going to work out each step of the way. We're going to do that in a coordinate plane. So have a coordinate plane handy. We're going to do this again, but it's going to be looking like this. Copy this, please. Example Q. It reads, example Q, it says graph f of x equals 3x minus 1 using the domain -2, -1, 0, 1, and 2. So to graph that function using that domain, what do we need? We need a what? A table. That is correct. So here's my table. X, f of x, and the domain -2, -1, 0, 1, and 2. That's our x values. We need to find our f of x. However, from there, we're going to do the transformation of another table, and it reads x is -2, -1, 0, 1, and 2. But this one has f of x plus 5 instead of just f of x. So here, we're going to do a transformation. We're going to do that one in green. And then underneath that or next to it, if you want to do another table, one more table, and it reads x -2, -1, 0, 1, and 2. And on f of x, we have f of x minus 2. We're going to do that in red. Okay? So we're going to start with the black one first, the original one. And I'm just going to show the work for 1 so you can see how this works. Okay? So here we go. So what's my first value that I need to use? -2, and that goes in here for the original function. So I write my original function, f of -2 equals 3 times -2 minus 1. F of -2 equals -6 minus 1. So f of -2 equals -7. And that goes right there. And we did plenty of practice with this, is that correct? On the warm-ups and other lessons. Yes, Mr. Q, thank you. Thank you, Mr. Q. You're welcome. Yeah. All right. So Instead of showing the work for the next ones, I'm just gonna show you right here. So if I was to substitute -1 in here, so what is 3 times -1? 3 times -1 is -3 minus 1, that's -4. Next one, what is 3 times 0? Because that's the next value, right? 3 times 0 is 0, and that leaves us with -1. Next value, 1. 3 times 1 is 3 minus 1, that's 2. And the last one, we're going to substitute the 2 in here. 3 times 2 is 6 minus 1, that is 5. Let's plot that. -2, -7. -1, -4. 0, -1. 1, 2. 2, 5. And get your ruler and sketch your line. There it is. And let's label this. This is f of x equals 3x minus 1. Okay. So now we're going to do the first transformation. I'm going to do that in green. So switch to green. And by now, guys, make sure you have your colored pens. Like I said, from this point forward, we're going to be graphing a lot. So make sure you have all your tools with you. Bam, Carlos in the house. All right, so I'm going to use green. So here we go. So it says f of x plus 5. So when x is -2, what is f of x? Well, f of x is over here. When x is -2, f of x is -7. So I would write -7 plus 5, and that is -2. Next, when x is -1, what is f of x? So x is -1 is over here. F of x is -4. So I would write -4, and that says plus 5, and that gives me 1. And then the rest we know what to do, yes? 0 plus 5 is 5. Oh, my bad. It was -1, sorry. -1 plus 5, that is 4. Next one, when it's 1, it is 2 plus 5, and that is 7. And the last one, when it's 2, that is 5 plus 5, and that is 10. All right, let's graph that. So we're graphing -2, -2, -1, 1, 0, 4, 1, 7, and 2, 10. Okay, -2, -2. -1, 1, 0, 4, 1, 7, 2, 10. All right, let me graph that in red. Get your ruler. Oh. There it is. Okay, and that looks pretty. All right, and we're gonna write for this one, we're gonna write that's g of x. Look up, guys. We're no longer gonna call it f of x because the f of x is the original one, yes? So now it's gonna be g of x because it's a transform into something else. So what happened for it to become g of x? Well, we took f of x and we did a parameter of +5. Okay, so here goes a big thought of this lesson. One of them, write your utensils down, pay close attention to this part. Here we go. So imagine right now somebody comes in, your little cousin, your little brother or sister, or that person that's always bugging all the time. You know, that you're eating flaming hot Cheetos, they want to take your flaming hot Cheetos. That you're playing games, they want to play your games, right? And let's say they walk in, but they are in elementary. They are in first, second grade. They don't understand any of this stuff that we do on the tables over here. But they're looking at this line. And you tell them, okay, well, look at this one. This is the original line. And they're going to say, so how did you get this green line? If this is the original, what would you tell them that you did to the original? Think about it. Don't say it out loud. What do you tell them you did to the original to get that new one without explaining any of this? What would you say? Let's see, help us out. Victor, what would you say? What would you tell your little bugging person that you do to the original line, this black line, to get to this green line? Roman, help him out.
I would just say I moved it up 5 steps.
Okay, so Roman said, I'll tell that person that I moved it up 5 steps. Let's see if it's true. I'm going to take this point. Let's see. 1, 2, 3, 4, 5. Okay, let's see if it works for this one also. 1, 2, 3, 4, 5. This one. 1, 2, 3, 4, 5. This one. 1, 2, 3, 4, 5. And this one. 1, 2, 3, 4, 5. Yes, it works. I move it up 5 steps. That is correct. Now that we made that observation, look up to the screen, please. Write your utensils down. What was my parameter for the transformation? +5. So the parameter, +5, it moved it up 5 steps. So look up to the screen. Without using this table, I want you to transform the original, but now using the parameter of f of x equals -2. Draw me that new function. You're like, oh, snap, Mr. Q. I'm telling you, we got this. So here comes your little cousin, your bugging little cousin again. What are you doing? Well, I need to do this red one, transform. So what would you tell your little bugging cousin, let's say that their name were Alberto. What would you tell Alberto?
Oh, I don't know, because I always close my door. I lock it and I'm like, there's a sign outside.
Okay.
Not disturb.
All right. Jessica, what would you tell Alberto that you're gonna do to the new to get that new transformed line?
I'm moving the line down 2 steps.
Moving the line down 2 steps. That is correct. So we go from here, this point, I go 1, 2. This point, I go 1, 2. This one, 1, 2. This one, 1, 2. This one, 1, 2. This one, oh, and that's the last one. Okay, so here it is, here it is, here it is. And I'm going to graph my line. Let me align it because it's a little crooked. All right. And what are we going to label this one? Once again, like I said, whenever we get to different transformations, the first one's going to be g of x. I can label this one g of x. I usually tell my students I can label it h of x, so it can be a different transformation. But for right now, I'm just going to leave it as in terms of g of x because we transformed the original one. So the new transformation g of x, what did we do to the original f of x for, whoa, sorry. What did we do to that original function to get that new transformation? Well, we took 2 steps down, or we do -2, so we write f of x -2. All right, so if we were to fill this in here, So what is the value when x is -2 of y and y is -9? When x is -1, what is y? Y is -6. When x is 0, what is y? -3. When x is 1, what is y? It's 0. And when x is 2, what is y? It's 3. The last value is 3. Okay. So let's see if we got this. So what can we conclude up to right there? That if the parameter is, let's say I continue giving you these kind of numbers, what can we conclude? That if a parameter is a positive, which direction do we go? Yes. If a parameter is negative, which direction do we go? Yes. Okay. All right. Let's see if you got it. Copy this next one on your coordinate plane. So I'm giving you a new function, and it reads, the graph of f of x is shown. Reference points, -1, -2, 1, 2, 3, -2, and 5, 2. So you have 4 points, and then go from the first point to the second, from the second to the third, from the third to the fourth point. Okay, so whatever that function may be. That's why I didn't give you a table, I just gave you a graph. So now that you know what to do with parameters, is that correct? I want you to do the following transformations. In green, it says graph in green, g of x equals fx plus 4. And in red, it says then graph in red, g of x equals fx minus 4. So do those two transformations. I'll give you 1 minute. Yeah? Yes, Mr. Q. All right, go. All right, let's see what we got. So for the green, the transformation is 4 steps up. Is that correct? Yes. So I take each point and I go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I label this what? G of x equals fx plus 4. What do we label this one in black? The original in black is f of x. Whoa, that was loud. And the red one, we take 4 steps in which direction from the original? Down. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And my function is g of x equals fx minus 4. Show me your fingers how comfortable you are with these. Yeah. 5, 5, 5, 5. Yeah, we got this. So now we know what those parameters do. So let's generalize the idea. So if I gave you the rule, write this down, g of x equals fx plus k. If I gave you the rule, g of x equals fx plus k. Once again, what do we call k?
K. K.
What is k called, guys?
Parameter.
Parameter, that is correct. Parameter. That's the parameter in which we're going to do the transformation. So if you were going to tell your little cousin what the parameter k does, what would you say, Angie? What does the parameter k do to a graph or the graph of a function?
It moves it up or down.
Moves the graph of a function, well, of a function up or down. That is correct. Up, once again, if it's a positive value, or down if it's a negative value. Woo. Oh, we got this. Let's crank it up a notch, yeah? Yeah, let's go. All right. On your new coordinate plane, copy this one. Example supercube, and it says graph the function f of x equals x squared using the domain -2, -1, 0, 1, and 2. So for that, we're going to need a table. So here's your table, x, -2, -1, 0, 1, 2, and f of x is empty. We're going to fill that in. And then we're going to do a transformation. Here's the transformation. X, we have another table in green. X is -2, -1, 0, 1, and 2. But this one says f of x minus 5 inside of the parentheses. And then one more transformation at the end we're going to do in red. X is -2, -1, 0, 1, and 2. And the new transformation at the end is f of x plus 4 in red. All right, so here we go. From now on, guys, whenever we introduce or whenever we're working with quadratic functions, which is this one, f of x equals x squared, this is what we call a parent function. That means from here, all the other functions are built up. So I'm going to do this one in green. I'm going to fill in this table. From this point on, you should memorize this table and the graph, because that's pretty much as easy as it is. So look up. So according to what I have here, this says x, -2, and then we have f of x. So f of x, or the function of x, what are we going to do to each x value? We're going to square it. Is that correct? Look up, look up. Yeah, if I substitute here -2, here -2, and I square it. So what is -2 squared? That is 4. So what is -1 squared? 1. What is 0 squared? 0, 1, and 4. Let's graph that. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And there's my parabola. And this is my f of x. I'll just leave it with f of x. Okay. All right, this is where it gets a little bit funner. So at this point, writing utensils down, look up to the screen. You'll finish copying a little bit. Focus, please. This is where I lose some of you. Focus, 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 please. Look up to the screen. I'm going to go to the transformation in green. However, look at this one. This one says f of x. For the other one that we did earlier, it said f of x plus 5 or whatever, and we just added a number here. Is that correct? But this one doesn't have the 5 outside of the parentheses. It has it inside of the parentheses, which is telling me to do something to x before I do the function. What do you mean, Mr. Q? Well, yeah, what are we going to do at here for each value? What did we do? We squared it. Or if I was to put this here, and I substitute this value in here, -2 squared is 4. -1 squared is 1, and so on and so forth. But I can't do that here. So if I bring down the square, check this out, and I substitute the x value in here, what would I write then? I would write the following. -2, which is the x. The transformation is what? -5. And then we're going to do what? Square it. Whoa, sorry. Give me a second. All right. So what is -2 and -5? -7. -7. And what is -7 squared? Well, that is 40.
49.
Yeah. So look at the next value. What is x? X is -1. What is the transformation? -5 squared, which is -6 squared, which is 36. You guys follow? Okay. So you're saying, oh, so we need to just do with the x and do that to the x first before we do whatever the function is. Yes. Next, 0 minus 5 squared, which is negative 5 squared, which is 25. Next, 1 minus 5 squared, which is negative 4 squared, which is 16. Next, 2 minus 5 squared, which is negative 3 squared, which is 9. Now you can copy that as I'm doing these. However, I'm going to keep going because if you notice, this one is negative 249. I can't graph that. I can't graph this one. It's too long, too big. This one's too big. This one's too big. I can graph 2, 9. Yes, I can graph that. So that means let me get another value here, 3. So that means 3 minus 5 squared, which is negative 2 squared, which is 4. I can graph 3, 4. Let me do another one, 4. 4 minus 5 squared, which is negative 1 squared, which is 1. I'll do one more, 5. 5 minus 5 squared, which is 0 squared, which is 0. All right, so I can't graph these, but I can graph these down here. So let me graph that. 2, 9, 2, 9. 3, 4, 3, 4. 4, 1, 4, 1. 5, 0, 5, 0. All right, so okay, look up really quick. Who notices that this transformation, whoa, sorry. This transformation, so far, it only gave me half of this one. Look at this half of the parabola, the original one. Do you guys see it right here? Do you guys see it? Now, if you don't see it, look up. Let me start with this original one. Look up. Notice here, these 2 points reflected on this side to create the other side of the parabola. So here, this one reflected over here, this one reflected over here. I can do the same thing with this green one. So watch. This one's going to reflect where? Right here. And this one's going to reflect where? Right there. And that one right there. Now do you see it? Okay. So you're saying, sorry, Mr. Q, where did you get these two? Like I said, when it's a parabola or a quadratic, these values reflect to this side because if you notice this here, the 4 became 4 down here, 1 is 1, so they just reflect. Okay. So here goes a question. Look up, please. Look up, look up. If I started off with x squared, there it is, which is this one. But now, here comes your little cousin. They walk into your room right now, and you tell them, okay, this is the original curve now. Oh, I see what you did to get this green one. What would you tell them you did to the original one to get this green one without showing them these numbers? What do you guys say?
I moved into the right 5 points.
Moved it to the right 5 steps. Moved it to the right 5 steps. 5 steps. Steps to the right. That is correct. Now check this out. Look at the parameter of the transformation here on the table. Look up. What was the parameter? -5. But it went 5 steps to the positive direction. So what can we conclude? That the opposite of this number is going to be the direction in which we go for the transformation. Is that correct? Okay, so question. Without filling in this table, and if I wanted to graph this transformation f of x plus 4, what do you think this is going to do to the original function? Who's got it?
Move it to the left.
Move it to the left. That is correct. It's going to move it to the left 4 steps. So each of these points, 4 steps. So we go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And there's our transformation. And that's pretty much what we're going to be doing for home plate today. Okay.
Homeboy.
Now, just to wrap this up, look up. So we have the parameter earlier. It was parameter K. Look up really quick. Don't copy this. Look up. We're almost done. If I was to give you the transformation, look up. F of x minus 2. What do I do to this function, Michael?
Can you repeat the question?
If this is my original f of x, what do I do with f of x minus 2 for my new transformation?
You move it to the left 2 times.
Close.
Oh,
Move it to
is
the
it down? Right?
right. Remember, the opposite of this one is positive 2, so we move it to the right 2 steps. So that means if I gave you this transformation, we move it which direction, John Jeet?
Oh, left.
To the left, 6 steps. That is correct. That's what we call the H parameter. And this is your general rule. G of x equals f parentheses x minus h. The H parameter. What does it do? It moves it to the left or to the right. I'm going to stop right there, guys. So once again, your home play for tonight is page 41, numbers 1 through 4. Your synchronous code QPT8S, and your home play were those 2 extra problems that I gave you aside from the ones on the page. A good one, guys. Enjoy your home play. Tutoring right after lunch, and towards the end of lunch, I'm going to put the home play so you can turn it in on Canvas. All right?
Later,
Later,
Are
guys.
you gonna have tutoring today?
Yes,
Mr.
right after lunch, tutoring. Yes.
All right, bet.